Dear children, welcome to this channel. In this video, I am going to continue the remaining examples under the topic Properties of Inverse Trigonometric Function and some of the exercise problems. Example 4.26. Show that cot of sin inverse of x is equal to root of 1 minus x squared by x, where x lies between minus 1 to 1 and x is not equal to 0. Okay. So, in order to show this, if we take sin inverse of x as theta, it will become cot theta. Cot theta means it will be equal to cos theta by sin theta. So, using sin theta, if we found out cos theta, then it will be, we can get the required answer. Okay. So, what you have to do? Let us take sin inverse of x to be theta, right? So, let us take sin inverse of x is equal to theta. So, this implies by definition x is equal to sin theta. Okay. So, we got sin theta as x. If we found out cos theta, then easily we can find out cot theta, and you can check whether cot theta is equal to root of 1 minus x squared by x. As x lies in the denominator, it has been given that x is not equal to 0. Okay. So, for sin inverse of x, you know that the domain, that is x should belongs to minus 1 to 1 for sin inverse of x to be well defined. So, here it is clear, as x belongs to minus 1 to 1, sin inverse of x is well defined, so that we can take sin inverse of x as theta. Okay. And what would be the range of sin inverse of x means it would be the closed interval minus pi by 2 to plus pi by 2. But as x is not equal to 0, you have to exclude that 0 value, that because at x is equal to sin inverse of 0 will be 0. So, x is not equal to 0 means that sin inverse of x should not be equal to 0. Therefore, theta belongs to closed interval minus pi by 2 to 0 union 0 to pi by 2 open closed interval, or theta belongs to the closed interval minus pi by 2 to pi by 2 excluding this 0, because as x is not equal to 0, sin inverse of 0 is equal to 0. As x is not equal to 0, that 0 should not be used, that should be excluded. So, whatever it may be, either 0 is included or excluded, theta belongs to the first quadrant as well as the second quadrant. Therefore, in this case, cos theta is positive. Okay. As in these quadrants, in these two quadrants, cos theta is positive. So, since cos theta is positive implies cos theta is equal to root of 1 minus sin squared theta, that is equal to root of 1 minus x squared. Therefore, cot of sin inverse of x is equal to cot of sin inverse of x is theta. So, cot theta. Cot theta is nothing but cos theta by sin theta. So, cos theta is root of 1 minus x squared and sin theta is x, where x is not equal to 0 and also minus 1 less than or equal to x less than or equal to plus 1. Okay. Then example 4.27. Solve tan inverse of 2x plus tan inverse of 3x is equal to pi by 4 if 6x squared is less than 1. So, this is very easy to do this. This problem is very simple to work out, because there is a formula for tan inverse of x plus tan inverse of y, and it is equal to pi by 4. So, apply the right hand side of the formula, equate it to pi by 4 and get the value of x. So, this is very simple, because here directly we are going to apply the property. Okay. Then before we know that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy if xy is less than 1. Okay. So, here x is 2x and y is 3x, that is equal to 6x squared, and also 6x squared is less than 1, given 6x squared is less than 1. Therefore, we can apply the formula tan inverse of 2x plus tan inverse of 3x is equal to tan inverse of 2x plus 3x divided by 1 minus 2x into 3x, that is equal to tan inverse of 5x divided by 1 minus 6x squared. Okay. And this is equal to pi by 4. So, given this tan inverse of 2x plus tan inverse of 3x is equal to pi by 4. So, this implies that tan inverse of 5x divided by 1 minus 6x squared is equal to pi by 4. That is 5x by 1 minus 6x squared is equal to tan pi by 4, which is equal to 1. So, cross multiplying we have 5x is equal to 1 minus 6x squared, or 6x squared minus 5x, okay, minus, 6x squared plus 5x minus 1 is equal to 0. So, if we solve this, 6 1 6 and then plus 6 and minus 1 is here. So, if we solve this, so what would be the factor? 6 ones are 6 and here plus 5 is there. So, plus 6 and minus 1 would be the factors, and as the coefficient of x square is 6, if we divide it by 6, we have 1 and minus 1 by 6 would be the, yes, so what would be the factor? X plus 1 into x minus 1 by 6 is equal to 0. That means these are the two factors. So, if you will get the value of x as minus 1 and plus 1 by 6. Okay. But that means that you have to check whether the two values satisfies the given condition 6x squared is less than 1. Okay. So, if we substitute x as minus 1, what happened to 6x squared? 6 into minus 1 the whole squared will be 6, but it is greater than 1. So, it does not satisfy the condition 6x squared is less than 1. That is, x is equal to minus 1 does not satisfy the given condition 6x squared is equal to less than 1. Therefore, and what is let us check whether 1 by 6 satisfies this condition. So, what would be 1 by 6? When we substitute x as 1 by 6, it would be 6 into 1 by 36, that is 1 by 6, which is always less than 1. And therefore, what is the solution? The required solution x is equal to 1 by 6. Okay. Therefore, the required solution is 1 by x is equal to 1 by 6. So, after getting the solution, you have to check whether it satisfies a given condition, if condition is given. Otherwise, whatever the value of x is obtained, you can write it as a solution. Next example 4.28. Solve tan inverse of x minus 1 by x plus 2 plus tan inverse of x plus 1 by x plus 2 is equal to pi by 4. This is just similar to the previous example. There the condition is given, here the condition is not given. So, directly you can apply the problem irrespective of the condition whether xy is less than 1 or greater than 1. Okay. So, directly we can apply the formula. So, what would be tan inverse of x minus 1 by x plus 2 plus tan inverse of x plus 1 by x plus 2 is equal to pi by 4 is given. Okay. Then applying the formula for tan inverse of x plus tan inverse of y, no need to check whether the product of these two is less than 1 because no condition has been given. So, you have to take that it has been given such that the product would be less than 1. Okay. So, tan inverse of x minus 1 by x plus 2 plus x plus 1 by x plus 2 divided by, here it is minus 2. In the problem it has been given as minus 2. So, it is x minus 1 by x minus 2 and x plus 1 by x plus 2 divided by 1 minus x minus 1 by x minus 2 into x plus 1 by x plus 2 is equal to pi by 4. Okay. So, moving this tan inverse to opposite side, we will get tan pi by 4. So, let us simplify the term inside the bracket. So, what would be the LCM? X minus 2 into x plus 2 will be the LCM. So, it should be multiplied here. So, x minus 1 into x plus 2 plus x plus 1 into x minus 2 divided by x minus 2 into x plus 2, that is a simplification of the numerator, divided by. Then again x minus 2 into x plus 2 is to be multiplied with 1. So, x minus 2 into x plus 2 minus of x minus 1 into x plus 1 is equal to tan pi by 4. Okay, we have moved tan inverse to opposite side in order to get tan pi by 4. Now, divided by, I left out the x minus 2 into x plus 2. So, these two get cancelled. Okay. Now, simplifying the numerator as well as the denominator, we have here x squared minus x plus 2x will be plus x, then minus 2 plus x squared plus x minus 2x is minus x minus 2 divided by. Okay. Then here it would be x squared minus 4, then minus of x squared minus 1. It would be x squared minus 1. So, when multiplying it will be x minus x squared plus 1, which is equal to tan pi by 4 is 1, right. Then simplifying the numerator, plus x and minus x will get cancelled, 2x squared minus 4. And what happened to the denominator? Plus x square minus x square will get cancelled, and minus 4 plus 1 is 3. Okay, and then if you move this 3 to minus 3 to opposite side, it will be equal to minus 3, or 2x square minus 3 equal to minus 3 plus 4 would be 1. This implies that x squared is equal to 1 by 2, or x is equal to plus or minus 1 by root 2. So you got two values for x, that is plus 1 by root 2 and minus 1 by root 2. Here no condition is given in the sum, so no need to check whether plus 1 by root 2 or minus 1 by root 2 satisfied. So whatever you have obtained, that would be the solution. So what is the solution for this problem? Plus or minus 1 by root 2 is a solution. Okay. Then last example 4.29. Solve cos of sin inverse of x divided by root of 1 plus x squared is equal to sin of cot inverse of 3 by 4. Okay. So here this is we cannot apply any property here directly, but we have to apply it somewhere indirectly. Okay. Let us find out the right hand side value first, because it is cot inverse of 3 by 4, sin of cot inverse of 3 by 4. So in such cases, two different ratios are given means, and moreover the value 3 by 4 doesn't represent any cot value of any specific angle. Okay. So in that case, what you have to do, you have to construct a right triangle and then take it to be theta, and then you will get cot theta. From that, whatever the ratio comes outside, you have to find it that value. That means if sinus comes outside, means you have to find out sin theta, so that theta will be sin inverse of that value. And then you can use sin of sin inverse of that value, theta equal to theta. Using that property, we can get its value. Okay. So in such cases, two different ratios are given, and moreover, if the value doesn't represent any specific ratio of the specific angle, then you have to apply the right triangle formula. Okay. And then here, by property number 9, there is an identity which resembles that property, which resembles the identity here. This sin inverse of x by root of 1 plus x squared represent and reminds the identity under property number 9. Okay. So what is that identity means? We have tan inverse of x is equal to sin inverse of x divided by root of 1 plus x squared, which is also equal to cos inverse of 1 by root of 1 plus x squared. Okay. This is by property number 9. Okay. By property number 9, and this is the fourth identity under property number 9. Tan inverse of x is equal to sin inverse of x by root of 1 plus x squared, which is also equal to cos of 1 by root of n plus x squared. So this reminds this identity, so that we can apply the sin inverse of x by root of 1 plus x squared as cos inverse of 1 by root of 1 plus x squared, and outside the external function is cos, so that we can apply the cos of cos inverse formula. Okay. So that's why we are using this property. So what happened to the left hand side? Left hand side will be cos of sin inverse of x by root of 1 plus x squared is nothing but cos inverse of 1 by root of 1 plus x squared, that is equal to 1 by root of 1 plus x squared. Okay. Now coming to the right hand side, let us take a cot inverse of 3 by 4 is equal to theta. So let us take cot inverse of 3 by 4 equal to theta. This implies that cot theta is equal to 3 by 4. So in this case, what you have to do, you have to construct a right angle triangle. So here cot theta means adjacent cos theta by sin theta, that is adjacent by opposite is equal to 3 by 4. So adjacent is 3, opposite is 4. So what would be the hypotenuse? Hypotenuse will be equal to 5, because 3, 4, 5 forms an Pythagorean triple. So hypotenuse would be 5, right? And then as the external function is sine, let us find out sin theta. So this implies that sin theta is equal to opposite by hypotenuse, that is equal to 4 divided by 5, and hence theta is equal to sin inverse of 4 by 5. Okay. Now we can find out the right hand side. So what is the right hand side? Right hand side is sin of cot inverse of 3 by 4, that is equal to sin of cot inverse of 3 by 4 is theta, and theta has been now transformed to sin inverse of 4 by 5. So sine inverse of 4 by 5 which is equal to 4 by 5. So we have to do this adjustment, whatever the external angle, you have to find out that corresponding ratio, okay, and then you have to find out the value of theta in that inverse and substitute here to get the required answer. This is the way to do the problem in such cases, right? And therefore as left hand side and right hand side are equal, we have 1 by root of 1 plus x squared is equal to 4 by 5, okay. Then cross multiplying we have 5 is equal to 4 into root of 1 plus x squared, right. Then squaring on both sides we have 25 is equal to 16 into 1 plus x squared. 1 plus x squared is equal to 25 by 16, or x squared is equal to 25 by 16 minus 1, that is 9 by 16, and x is equal to plus or minus 3 by 4. So no condition has been given. So whatever the value of x has come, finally would be the solution for the given problem. Let us do the exercise problem. Exercise 4.5. The first one is find the value if it exists. If not, give the reason for non-existence. Okay. So the first subdivision is sine inverse of cos pi. Second one is tan inverse of sine of minus pi pi by 2. And third one is sine inverse of sine phi. Right. Now let us do the first subdivision. First problem is sine inverse of cos pi. Right. So sine inverse of cos x is equal to sine inverse of cos x can be written as sine of pi by 2 minus x, okay. And if x belongs to the closed interval 0 to pi, and then sine inverse of sine will be pi by 2 minus x. Already we have seen this formula as a remark. Sine inverse of cos x is equal to pi by 2 minus x if x belongs to the closed interval 0 to pi. So this is the way we have obtained the formula there. So let's apply, as pi belongs to this closed interval, we can apply this formula for this. So sine inverse of cos pi is equal to pi by 2 minus pi, that is equal to minus pi by 2. So here the value exists, right? And what is the value? That is equal to minus pi by 2. Now let us come to the second problem. Second one is tan inverse of sine of minus 5 pi by 2. So first let us find out what is the value of sine of minus 5 pi by 2 and substitute here, okay. So sine of minus 5 pi by 2 is equal to, sine of minus theta is minus sine theta, so that is minus sine of 5 pi by 2. So let us evaluate this sine of 5 pi by 2. 5 pi by 2 can be expressed as 2 2s are 4 plus 1 is 5. So 2 pi plus pi by 2. So that is nothing but minus sine pi by 2, right. 2 pi plus pi by 2 will be pi by sine pi by 2. Sine 90 is 1, that is equal to minus 1. Therefore, tan inverse of sine of minus 5 pi by 2 is equal to tan inverse of minus 1. And you know that tan inverse of minus 1 is nothing but minus pi by 4. So in this case also the value exists, right. Then third subdivision, try by yourself, because we did a similar example. Sine inverse of sine 10. Instead of 10, here it is 5 is given. So just apply the same method and try by yourselves, okay. Try by yourselves. Just as an example, sine inverse of sine pi, and the answer would be 5 minus 2 pi, okay. The answer would be 5 minus 2 pi. Check it. The same way you have to proceed. Second one is find the value of the expression in terms of x with the help of a reference triangle. First subdivision, sine of cos inverse of 1 minus. Second one is cos of tan inverse of 3x minus 1. And third one is tan of sine inverse of x plus 1 by 2. So I am going to do the third subdivision so that you can have a try on the first two, okay. So let us do the third one. So what is the third problem here? Tan of sine inverse of x plus 1 by 2. See, if two different ratios are given and if the term inside the bracket is known angle or known value, means then it would no problem. You can find its value and then substitute here as in the previous example. But here, whenever it is given as a variable or in numbers, if it is a numerical value which does not represent ratio of any specific angle, means what you have to do? You have to use a triangle. you have to construct a right angle triangle and you have to find out the required ratio. Okay. So in the here it is given as well as the question itself given, you have to use a reference triangle, right? So what you have to do in this case, let us take the interior function, that is sin inverse of x plus 1 by 2 as theta. So let us take sin inverse of x plus 1 by 2 is equal to theta, which implies sin theta is equal to x plus 1 by 2. So with the help of that, we have to find out the required ratio, whether it is tan or cos or cot. But here the function is tan, outside external function is tan, so you have to find out tan theta. If it is cos, you have to find out cos theta. If it is cot, you have to find out cot theta. So in this way, you have to proceed. So let us form a right angle triangle in which theta is the acute angle. As sin theta is x plus 1 by 2, we can write it as x plus 1 by 2 divided by 1. So opposite side will be x plus 1 by 2 and hypotenuse is 1. So let us find out the adjacent side in order to get the value of tan theta, right? So adjacent side is equal to square root of hypotenuse square is 1 minus x plus 1 by 2 the whole square. That is square root of 1 minus, we can write it as 2x plus 1 by 2 the whole squared. Okay. So root of 2 squared is 4. So 4 minus of 2x plus 1 by 2 the whole square divided by, outside the root it will become 2. That 4 will become 2 outside the root, right? Then simplify the term inside the root. 4 minus of, expand this, that is 4x squared plus 1 plus 4x by divided by 2. Then square root of 4 minus 4x squared minus 1 minus 4x, okay, divided by 2. That is equal to square root of 4 minus 1 is 3, 3 minus 4x squared minus 4x divided by 2. This is our adjacent side, okay. And then we need tan theta, as the external function is tan. So let us find out tan theta. So what is tan theta? Tan theta is opposite side by adjacent side. Opposite side is x plus 1 by 2. That means we can rewrite it as 2x plus 1 by 2. So 2x plus 1 by 2 divided by adjacent side is root of 3 minus 4x squared minus 4x divided by 2. So these two and these two get cancelled. So what will tan theta? 2x plus 1 divided by root of 3 minus 4x squared minus 4x. And therefore what is theta? Theta is equal to tan inverse of 2x plus 1 divided by root of 3 minus 4x squared minus 4x. Okay. Now let us substitute here. Tan of sin inverse of x plus 1 by 2 is equal to tan of, this is theta, that is tan theta. So what is tan theta? Tan theta is directly, we can write it here, or that is 2x plus 1 divided by root of 3 minus 4x squared minus 4x. Even no need to replace it at tan inverse and use applied identity. Directly you can write tan theta. Tan theta is equal to 2x plus 1 divided by root of 3 minus 4x squared minus 4x. So we have expressed this value in terms of x. In this way you can try to do the first one as well as the second one. So in this case, if you take 3x, tan inverse of 3x minus 1 as theta, you will get tan theta. From that, by constructing the triangle, you have to find out cos theta, the value of cos theta, okay. And then here taking cos inverse of 1 minus x as theta, you have to find out the value of sin theta by constructing the triangle, and then find out the value which will be in terms of x, okay. So what the answer for the first subdivision is square root of 2x minus x squared, and for the second subdivision is 1 by root of 9x squared minus 6x plus 2. So you can check whether you will get the corresponding answers, okay. This would be the value which is expressed in x, okay. You have to proceed as in the third subdivision, proceed in the same way, right. Now let us come to the third one. Find the value of, first subdivision is sin inverse of cos of sin inverse of root 3 by 2. And second one is cot of sin inverse of 3 by 5 plus sin inverse of 4 by 5. And third subdivision is tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2. Okay. The first one is simple, so you can do, because root 3 by 2 is a ratio of certain value, specific angle. So first let us find out what is sin inverse of 3 by 2. Then substitute that value and get cos of that one. and then after getting that one, substitute here sin inverse of that value, you will get the required answer. And therefore, what would be the answer for the first one? It would be pi by 6. Okay, the answer for the first subdivision would be pi by 6. Check down. Okay, now let me do the second one. So as it is very simple, I left this problem for you. Then second one is cot of sin inverse of 3 by 5 plus sin inverse of 4 by 5. So here, even though it resembles the formula sin inverse of x plus sin inverse of y, but sin inverse of x plus sin inverse of y means it would be a very big formula, that is sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. So you have to use a root and then it will be somewhat bigger. Instead, if we replace this by cos inverse, then by the cofunction inverse identity, we can apply the form, we can easily write down the answer as pi by 2 if it is cos inverse. Okay. So let us check whether it would be equal to cos inverse of 3 by 5 to apply the cofunction inverse identity. So in that case, moreover 3 by 5, 4 by 5 doesn't represent the ratio of value of any ratio of the specific angle. So what you have to do in that case, you have to represent, draw a right angle triangle and you have to find out the corresponding value, right. So let us take sin inverse of 4 by 5 to be theta. So let sin inverse of 4 by 5 is equal to theta. This implies that sin theta is equal to 4 by 5. So by representing this in a right angle triangle, it would be the opposite side is 4 and adjacent side will be 5. Then what we are going to do, we are going to express this in terms of cos and you are going to check whether cos inverse will be 3 by 5. Cos, it would be cos inverse of 3 by 5. Okay. Now what would be the adjacent side? Adjacent side will be equal to 3 because 3, 4, 5 forms a Pythagorean triple, and therefore what is cos theta? Cos theta is equal to 3 by 5 and therefore theta is equal to cos inverse of 3 by 5. So sin inverse of 4 by 5 can be now replaced by cos inverse of 3 by 5. Okay. Now cot of sin inverse of 3 by 5 plus sin inverse of 4 by 5 will now become sin inverse of 3 by 5, right as it. Now we have found out sin inverse of 4 by 5 is equal to cos inverse of 3 by 5. Then by the cofunction inverse identity, it will be equal to pi by 2. So cot pi by 2, since sin inverse of x plus cos inverse of x is equal to pi by 2. Okay. Therefore, this will be equal to pi by 2 and hence cot pi by 2. What will be the value of cot pi by 2? That is 1 by tan 90. Tan 90 is infinity. So 1 by infinity will be 0. So what is the value of the given expression? It would be equal to 0. Right. Now let us do the third subdivision. What is the third one? Tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2. Okay. So in this case, in the previous one we have got a sin inverse. So we checked whether that sin inverse can be expressed as cos inverse by constructing the triangle. But here it is somewhat different, a cot inverse. There is no relation connecting sin and cot, right. So let us do this by another method. Okay. Now let us take cot inverse of 3 by 2 to be some theta or theta pi. Okay. Let us take to be some pi. This implies that cot pi is equal to 3 by 2. So cot pi means what would be tan pi? Tan pi is equal to 2 by 3. So what we are going to do in this case, as in the previous one, we cannot express this by cos because 3, 4, 5 will be the Pythagorean triple. There we had 4 by 5, 3 by 5. So we used the Pythagorean triple and we expressed sin inverse of 4 by 5 in case of cos inverse of 3 by 5 and applied the cofunction inverse identity. But here 3 by 2, it is somewhat different. Okay. So that's why we are going to use this method. So what we are going to do, let us express both in terms of tan so that we can apply the tan inverse of x plus tan inverse of y identity here. Okay. Do you understand why we are doing this transformation now? So let us take this cot inverse of 3 by 2 as pi, so that cot pi will be 3 by 2 and hence tan pi will be 2 by 3, right. Now here sin inverse of 3 by 5. So let us take this sin inverse of 3 by 5 to be some theta, and this implies that sin theta is equal to 3 by 5. So let us express this also, find out tan theta so that we can apply the formula there. So by using the right angled triangle Sin pi is 3 by 5 means this would be 3 by 5 and hence adjacent side will be 4 and hence what would be tan theta? Tan theta is equal to opposite by adjacent, that is 3 divided by 4. Okay. Now tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2 is equal to tan of, this is theta and that is pi. So here we got a formula of tan of a plus b. So what is it? Tan a plus tan b divided by 1 minus tan a into tan b. Directly we can apply this formula instead of changing it as tan inverse. Okay. So we can use this formula tan theta plus tan pi. What is tan theta? Tan theta is 3 by 4 and tan pi is 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. So taking LCM as a 12, 9 and then 4 to 8, that is equal to 17. Okay. And divided by here 3 fourths 12, 12 minus 6, that is 6 divided by 12. So that would be equal to 17 by 6. So what is the value of the given expression? It is equal to 17 by 6.